Welcome to the third lesson in building your own custom image segmentation pipelines. So I'm going to be using the Detecto library, which runs on PyTorch, and the Detecto library makes it really, really simple in order to build your own custom image segmentation problem. So to do that, we need to make sure that our data is formatted correctly, and I showed you how you can do that from last lesson. So to recap from last lesson, we have label image, which you create, you load an image and you put in some labels, and then we save it as an XML format. So let's have a quick look at what the XML format may look like. So this is the image that I had, that I showed in the last lesson, and this is the XML format that you get, right? And you get some bounding boxes and what format they're in. However, this particular format, you can't really directly just read it into, say, PyTorch. And there are lots of different utility files that you can find online to do it. For the Detecto library, it actually comes out of the box in terms of how you can process all of these XML files to a CSV file. So if I go to training .py that I have here, you see that there's a utils called XML to CSV, which will just take in all the XML files inside this folder and create a CSV. So if I have a look here, you'll see that there will be the file name, width, height, and a particular class for every single image that is in that folder. Alright, and that's really all you need in order to create the labels. So from there, the question is, well, how do I create the model? So to create the model, you can see in the following line, we just list the type of labels that we want in our data set. So for example, I've now added the label piano. This is a new label that wouldn't have existed in the default model because it's a new category that is unseen. And we can obviously throw in other labels in here as well. And of course, you can add in all of the labels that the previous model had. And then from there, we just list in the dataset and the folder. So the first argument is the list of the labels with the bounding boxes in the CSV format. And the second one is the folder in which all the images reside. And then from there, you can just call model.fit dataset and just cross your fingers and wait a bit. I'm not going to go into the particular parameters in terms of what you might see, but that's essentially the process that you do. And then from here, you can begin to have a play around with what things look like. So I'm going to just go into the temp folder, which has my example. Right. And if I show you the load run file, you'll begin to see how we may actually begin to label the image. So for example, in this particular example, if I create a model and just load in the labels that we need, you can use the utils read image to read the image, and then you can write the predict, and you will come up with a list of all the labels and scores and boxes. From there, you can do some filtering. So for example, I only want images with a certain level of confidence or probability, and you can choose to do that in this particular step. And then you can apply the particular bounding boxes that you're interested in via the visualize and show label. In my particular instance, I just wanted to show the top one label, which is why there was only one bounding box, and this is how you would do it. And when I ran this, the output that I got is the output that I showed you in the very first class, as you can see here. So there you have it. That's how you can build your own image segmentation pipeline in very, very few lines of code. So all in all, how many lines of code is this? This is 10 lines of code for the training, and for the actual prediction, it's probably roughly 10 lines of code as well. So within 20 lines of code, I've shown you how you can create your own custom image segmentation pipeline for not only training, but also prediction. So hopefully this has been useful for you, and hopefully you've learned something new about how you can create your own image segmentation pipeline and models.